All right, I'll just hit the button, and then you want me to aim for 40, 45?
Oh yeah, so that's off by 4 minutes.
No, I'm not gonna look at this one. I'm just gonna work with this guy.
Okay. Yeah, so 50 around the 50-minute mark is when we'll have the questions open. Alrighty.
So I need to touch base with her.
Oh yeah, I'm gonna move this out of the way. You're good.
Oh.
There we go. Awesome.
He's getting the name, but his wife, she's a
Alrighty. Testing. Alright.
okay.
Let's get started. Okay, welcome everyone. My name's Ezra Elisoff. I work here at Sealaska Heritage Institute. I work in the education department. I'm the education project coordinator for the grant Our Ancestors Echoes. As a gentle reminder, I'd like everyone to leave their drinks or any food outside of the clan house, and please put your cell phones on mute. So it is my honor today to welcome you all here today at the Empowering Community Language Workers with Technology lecture in our lecture series of 3 lectures under the theme titled The Future of Indigenous Languages. At Sealaska Heritage Institute, we are committed to growing new speakers by supporting and uplifting language teachers. Currently, 6 of our scholarship recipients are pursuing Indigenous language studies degrees at the University of Alaska Southeast, with a focus on Alaska Native languages. This lecture series is part of that broader effort and opportunity to explore how technology can support, strengthen, and language revitalization across our communities. Previously, on Friday, April 11th, we had started our lecture series off with Justin Langan, who talked about how AI can assist in Indigenous language revitalization and how it can engage young learners. On Wednesday, April 30th, we will have our 3rd and final lecturer on this topic, Nathan Bennett, who will talk about his work exploring how innovative technologies like AI and machine learning can support the revitalization of critically endangered languages. Today we have Dr. Rolando Coto-Solano representing Advancing Indigenous Language Technologies, who will present today's 2nd lecture on how advancing technologies will help shape and build the future of Indigenous languages. Advancing Indigenous Language Technologies, or AILT, Working Group is a coalition of academic and community language workers and scholars joining efforts to support the advancement of language technologies that serve Indigenous language community needs. AILT has launched in the summer of 2023 as a collaboration among 3 academic programs affiliated with the University of Arizona Department of Linguistics, College of Education, and the Department of American Indian Studies. The AILT co-founder, Dr. Rolando Coto-Solano, is from Costa Rica, and he works as an assistant professor in the Department of Linguistics and an adjunct assistant professor in the Department of Computer Science at Dartmouth College. He also works with computational linguistics, creating NLP tools to aid in the documentation of Indigenous languages. He has experience working with communities in Polynesia, Costa Rica, Arizona, Mexico, and Bolivia. At the end of the lecture, you will have the opportunity to ask questions. Those tuning in online will have the opportunity to ask questions in the comment section. Without further ado, I'd like to welcome Dr. Rolando Coto-Solano.
Thank you so much. Good morning, everyone. Thank you so much for being here. I would like to thank Sealaska Heritage and all of you members of Haida, Tsimshian, and Tlingit communities for welcoming me here. I come here representing a group called Advancing Indigenous Language Technologies. And for everything that I'm going to say, please keep in mind that even though I'm the one standing here, there's a huge team behind all of this, Co-founders Amy Fountain and Aresta Tsutsia Padok, who is Dene Navajo from Arizona as well, and professors Eric Jackson, professors, let me see, Gus Han Powell, John Ivins, Mike Hammond, amazing students like Jennifer Medina, Alice Kwok, Braden Thu, Yomi G, and Ross Freeman have worked really hard on many of the things that I'm going to show you. And for all of the examples of speech recognition, of how the computers work, there's amazing work by all of the individuals here. There's going to be some main characters in the story. For example, Sally Yakebai Nicholas is a colleague, a linguist from the Cook Islands, whose work has influenced our work a lot. Jean Tikura Mason is an amazing knowledge holder from the Cook Islands who is so generous with her stories, with her Polynesian genealogies, and so much so that she has given us so much of her voice that she is like the robot voice of the program now, as I'll show you in a few minutes. So an amazing team behind all of this. Again, I thank you for your time. And you've heard these kinds of things. That's why we're here, that AI is going to be this all-powerful tool, but of course, these claims can be greatly exaggerated. The idea that AI will replace humans in a lot of tasks, that AI is going to become incredibly intelligent in all of these. And certainly this has increased its capabilities in the last couple of years because of new algorithms that are coming out and incredible masses of information that we can use to train these new models. However, when working with indigenous languages, we can see some of the major weaknesses these algorithms have. Let me tell you, I'll tell you a little bit more in a second. I work with a community in Costa Rica called the Bribri. It's a beautiful language spoken by about 7,000 people. This is what happened when I asked ChatGPT for a conversation in the Bribri language. Could you read the English for a moment? Oh, you don't have to read it out loud. The most important part here is this is all made up. Not only is this complete gibberish, there's very, very little resemblance to Bribri. It's very strange gibberish because look at the things it's saying. It's not only very confidently saying, oh, this is how you say hello. This is how you say, how are you? It invented a festival. I'm going to show you, there's nothing like this. It invented a food festival. It invented a food tradition. It's worse than not knowing. It's impersonating an indigenous person as a computer. And this is obviously a very dangerous thing. And it has to do with how these models are amoral. They do not have a way of establishing relationality with people. They do not have clear understandings of who they're speaking to. There needs to be a lot of safeties in order to keep these models in check, and many of these do not really work when dealing with indigenous languages. So again, all of it made up. Bribri is a language that's spoken in Costa Rica, as I mentioned, by about 7,000 people. It is vulnerable in that there are children in the community who no longer speak the language. It's spoken here in the southern part of what is now Costa Rica. And there is data available if someone wanted the computer to learn Bribri. So colleague Sofia Flores has been compiling an oral corpus for a while. We're also starting to use our algorithms to try to annotate this a little bit more quickly. There are publications, textbooks that children use in schools, textbooks for adult learners, and so forth. So there are ways in which a computer could learn this language. However, it does not. What you see on the right is what it should have been. You can see that it's completely different. And I mean, just try to raise your hand. Have you tried asking ChatGPT if it can speak your indigenous language? How did it go? Yeah, not amazing. Indeed. Let me teach you one phrase of the Bribri language from Costa Rica. So, Cheque Rolando. How could you tell me what your names are? Say it. Could everyone say it? Cheque, and then your name. Hmm? There we go. Cheque Rolando. That's my name is so on in Bribri. I tried this last night just to make sure that it was still working the same. How do I say my name is? This is something that the computer could have potentially learned from existing textbooks, from existing sources, if it had taken the time to consult them properly. Nope, it made something up, which, as you can see, looks nothing like what we had in the model. The only thing true about the output is that vowels can vary slightly from one Riwi community to another. So at least it knows that much. I tried this model, the DeepSeek R1 model, which is a model made in China. How do I say my name is Rolando in Riwi? It has the exact same problem. As you can see, it makes up something. The ideal behavior for these types of computer models would be, I don't know, I'm not going to try. Or maybe try to learn it properly, but this is a very expensive thing to do. They shouldn't just make things up. So we do have a problem here. We've heard that artificial intelligence can be helpful for a lot of things, that it can accelerate the work that we do, but whenever we try it, we get weird results like these. How can we use computers in ways that are helpful to language workers, in ways that actually lighten the workload and that help them do what they do best, which is teaching the language, transmitting the cultures, things that the computer could not really understand? We got an NSF grant in 2024 for the program Advancing Indigenous Language Technologies to try to do surveys of technology, to try to detect technology needs in Indigenous communities, trying to offer workshops on some aspects of technology. We have our roots in two programs from the University of Arizona. The first one here to your right is the American Indian Language Development Institute. It started in 1978 under Ofelia Zepeda, who you have here, and for more than 45 years now, AILT has been offering courses on curriculum development, language immersion, language surveys, and in the last couple of years, we have been teaching classes on Indigenous language technologies as well, linguistics and technology. Our University of Arizona also has a master's program called the Native American Languages and Linguistics Program, NAMA, which has trained an entire generation of linguists from Indigenous communities, not just in the Southwest, but all over the United States, and linguists from Indigenous Latin America as well, to describe their languages, to go on to do PhDs in linguistics, for example. And again, because these two efforts were related to language documentation, we have seen how there are some bottlenecks in all the process, some things that are very difficult and that maybe technology could help us with. We have conducted workshops on topics like database design, for example, databases to have vocabulary that don't require buying external software, for example. We have done workshops on predictive keyboard creation for phones. We have workshops on technologies like Flex, for example, for dictionary making. We have done workshops on training speech recognition systems for Indigenous languages. And in general, we're trying to think of this question of what is it that the computer should be doing. In the computer science world, usually we think of one of these computer artificial intelligence models as something that should solve a task, and then the humans should do some kind of menial labor to get the computer to be better. So for example, in speech recognition, we just need a bunch of humans there annotating all of our Flex transcriptions to try to get the computer to do a few points better, and so forth. And this is a painful cycle that we have in computer science for machine learning because it only really benefits the computer. Maybe in the best of cases, some of the money for the labor will go to community members, maybe it won't, but it's certainly not what we want to do. We don't want computers to learn this for computers' sake. And I mean, even think about it, like now we're talking about the perfect AI model. 10 years ago, we would have been talking about the perfect app. 20 years ago, we would have been talking about the perfect website. 30 years ago, for those as old as me, we would have been talking about the perfect CD-ROM to learn languages. These large language models, they're going to have the same technological cycle. Eventually, in 10 or 15 years, they will be obsolete and it will be worthless for one of these things to know an Indigenous language. This gains us nothing. What we need is something where teachers, learners can interact, and somehow the computer can lighten their load. And to have a computer that can help you when you're doing description, do your transcriptions, break up the morphemes, any of these kinds of applications. And just let me ask you real quick, could you raise your hand? Has any of you had to do like transcription of audio recordings? Yes, isn't that one of the most difficult activities you've ever had to do? It's just so time consuming. You can't listen to music while you're doing it. You have to be all there. It's an interesting task because it's really monotonous, but also requires incredible amounts of expertise. You need a lot of knowledge of how the language works. You need a lot of experience, and yet it's also something that's repetitive, etc. It really looks like something that a computer could help with. So tasks like transcription, tasks like translating, for example, annotating these collections that we have when we have recordings in order to then make grammar sketches, pedagogical grammars. We need to understand how certain parts of the language work. Annotating this is a difficult and expensive process. And we need all of these to eventually make our teaching materials, make the materials that we need for things like language classes. So I'm going to tell you a little bit about experiences from the Advancing Indigenous Language Technologies team and also from my own experience working with artificial intelligence and language documentation. And I'm going to show you some examples for these technologies, one called forced alignment, speech recognition, calculating text to speech, doing something we call parsing, which is describing the elements in a sentence, the types of words, the types of relationships between words. We're going to talk a little bit about machine translation, and then in concrete computer applications that can support speakers and learners in the journey. So I told you a little bit about the Bribri language, which is spoken in Costa Rica, and now you know how to say my name is. So Costa Rica is around here. We're somewhere way above here. Yes, not on the map. Somewhere in the middle, there's an archipelago called the Cook Islands. And it has some places like Rarotonga, which is the largest island, that are very visited by tourists, and some places like Mauque, for example, Mitiaro, that are small islands, maybe populations of 200 people, that not a lot of people visit. This is one of the people that I told you would be one of the main characters of the story, Sealaska Nicholas. She is a linguist from the Cook Islands, trained in New Zealand, and I met her in New Zealand. I worked for a couple of years there in Aotearoa, New Zealand, and she had recorded dozens of hours of, again, genealogies, stories, Polynesian stories, and said that she was going to die before finishing transcribing all of this. I don't know if this sounds familiar to any of you. And we offered to try to see if we can build something to help with this. As a good computer engineer, we promised it would be ready in 2 years, and it was more like 4 years when we could do it. The language itself has about 13,000 speakers in the Cook Islands and about 8,000 more speakers in New Zealand and Aotearoa, New Zealand and Australia. Most of the population is in New Zealand and Australia because they have a New Zealand passport. They can easily move back and forth. Rarotonga, which is the largest island, the language is endangered there, and the language is vulnerable in some of the other islands. Some children speak it, some don't. By the way, this is going to be important in a minute. This is the island of Aitutaki, which is right here. It's an island that Pan Am flew to. It was part of like this plane that hopped all the way from San Francisco to China in the 1930s. It's like a beautiful pearl, as you can see. Many people go there on vacation. This is Rarotonga, the bigger island, as you can see. Also beautiful. Many people from Australia, from New Zealand go there on honeymoons. And during her work, Professor Nicholas has collected, again, dozens of hours, worked very hard to transcribe it on software like Elan, and transcription has always been a major bottleneck in that there's a lot more materials that we could be transcribing. When we started the project, there was about 1 hour. We ended up with somewhere between 4 and 5 hours of annotated data, and that took a little bit over a year. Let me first tell you about this technology, forced alignment. So in forced alignment, you get an audio signal and then a transcription at the phrase level. For example, you tell the computer that from second 5 to 8, you have the phrase to ratel. What this algorithm does is that it can find where in the signal you have specific words and even specific sounds. So you can, for example, have a storybook that reads along and marks the words as you go. I'll show you an example in a second. Or even you can have specific vowels and then describe properties from these vowels. Interestingly, we piggybacked off an English model. For human languages, obviously things like words and structures are very different between languages, but human sounds don't have infinite variations. Some, for example, the vowels in the vowel a in Hungarian is going to sound a little bit like the vowel a in Bribri. We can use this kind of model to get the computer to interpret new situations based off of old knowledge. This is what we did here with untrained forced alignment. We basically told the computer to think that the words toratau in Cook Islands Maori were toratau in English. It's like we were teaching it two new words of English and tell it, even if you have never heard it before, try to find them there. From doing this, let me show you an example of a pattern that we got. These are the vowels I, E, A, O, U. The relative position is not as important as the fact that you can see that these two guys here are not quite in the same position. They have moved towards a more central position. And look at our suspects. Aitutaki, the beautiful island on the Panam route, and Rarotonga, the one where the honeymooners go. Whereas these, Atiu and Mauke, are smaller islands, 200 people, very few people go there. Something very interesting is happening here. We think that things like tourism and higher contact with English is changing the Cook Islands Maori language. This position here resembles the way people pronounce the U in things like American English, a little bit of New Zealand English, where we don't say moon, but we say something like moon, where the vowel is somewhere around here. We think that because of tourism, the sounds of the language are changing to become more like English in the islands that have more contact with English and are staying more Polynesian, for example, more like Samoan or Tongan in the islands that don't have as much contact with English. And we managed to learn this because we managed to analyze the signal very rapidly and managed to get a couple thousand vowels from this untrained mechanism. So there's actually many islands around here, so this might be familiar to some of you all. If you're on an island, if you go right or left, eventually you're going to end up in the same place where you started. Something that would be useful on an island would be a coordinate system where you can say that you're going towards the sea, towards the center of the island. In Cook Islands Maori, the word like sea words is tai. The word for one is ta'i with a glottal stop. Tai, ta'i. You all want to try to say it with me? Tai, ta'i. Yes. No pause? Pause. While we're doing the project, we were working on a class to train language teachers in the Cook Islands. These are people who are taking a diploma in linguistics, and they're the ones who really need to know how vowels work, etc. And from some islands, they said, these two words sound exactly the same. We shouldn't be writing the apostrophe. And then some islands said, they sound completely different. We completely need the apostrophe. So this is what, you can see where this is going. This is one of these classic, like two varieties. Let's see what happens. We used this corpus of thousands of vowels that we managed to accumulate to study what was happening in these particular types of words. So one interesting thing that can happen to this little sound, which is technically called the glottal stop, it's like a little pause in your throat, is that you can have a total closure. You can say ta-i, ta-i. But if you don't close your vocal cords completely, a little bit of air is going to go through and it's going to sound like tai, tai. You might have heard this in English, people call it creaky voice, where you say a vowel like ah instead of ah, for example. So here in this chart, closure means that these two are completely different because they pronounced ta'i with a complete pause of the air. Creak means that the vocal cords were closed only partially. Tai. And zero means that there was no difference between these two words. And you can see that every island is kind of doing its own thing. So in Mauke, there's a total closure with the glottal stop. They tend to say ta'i for one. Whereas people in Atiu here, about 50% of them would pronounce both of these as the same word, tai, tai. And, for example, here in Rarotonga, there is a relatively high proportion of speakers that pronounce this with what we call creaky voice. So the difference between these two would be tai, 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 tai. But anyway, we have some evidence that this phenomenon happens in Hawaiian, in languages in French Polynesia as well. So we could come to them with an answer. We told them there are differences in this. Even for when sometimes difficult to hear, the glottal stop is still there. It was interesting because these were teachers. So the first thing they did about it was make a song about the glottal stop. And in the feedback, they would talk about how proud they were, about how complex the language is, which of course it is. And we go back to these painful cycles about them being told that the language was simple, English was better, and trying to break this cycle. So even something as esoteric as aligning these vowels and extracting information from it can be very impactful for teachers. I mentioned in the chart that these types of algorithms can be used to find sounds, but also words. There's applications like the Read Along Studio. This was made by amazing people, Aidan Pine at NRC, that can use a similar algorithm to sort of read along. If you have text, the computer can follow along and find where the specific word is and mark it. You know what? I will show you what it looks like right now.
Manu te kota a tōku ingoa, e no ana au ki manuai, no manuai mai au. E manu tauturu arataki mai au.
Yay. This is the story of a cheeky bird. It's Manu's unhelpful travel guide to the Cook Islands. And you can see how the algorithm itself is finding where each of the words lives.
Manu a tōku ingoa.
Not perfect, but it does help
Ingoa, e no ana au ki
follow along when you're reading. Speech recognition. So what I showed you is an algorithm where the computer can understand sound and try to connect the audio sound with some written signal. But of course, the main headache that we have, and the main reason why I got into this, is because transcription is so difficult. It is not as easy as transcribing English, with a lot of people not only would know how to do it, but also would agree on how to do it. People have calculated up to 50 hours of work for transcribing 1 hour of audio in Indigenous languages. And that is if people agree. Different members of the community might disagree on orthographies. Maybe different parts of the community use different orthographies. And this bottleneck slows down everything else. And this technology, even though it's not perfect by a long shot, it does exist for other languages like English. So we can piggyback off of those algorithms. As I told you, one of the main things that we did was try to transcribe data. This is an example of how we transcribed it in Elan, and we got about 4 hours of transcriptions from 10 speakers from 4 different islands. We have worked very hard since to try to improve it, but the results I'm going to show you are from a model with 4 hours of training. We took them and we trained a mechanism that had approximately 5% of what we call character error rate. I will show you what that looks like in a moment, and about 11% of word error rate. This means that out of every 100 letters that you type, about 5 are coming out wrong, 95 are correct. As for the words, about 89 out of 100 are correct, 11 out of 100 are wrong. This is what that error looks like. So this is a sentence that has 80% of its words wrong and 50% of the characters wrong. For example, because there's a long vowel, but a short vowel here, it's missing glottal stops, it's missing an A.
Okay. Okay.
So you can see that even if this transcription here, the ASR transcription, is not perfect, it is something that we can work with. It is something that then correcting it would take less time than transcribing it by hand, which was our goal for a couple of years, trying to get to a point where this would actually be useful. This is an example of something that whose transcription is not great. This is an example of a transcription that worked really well.
Ito
As you can see, the errors here are the computer failed to identify one of the letters, the computer lengthened a vowel. The poor computer, Ishan, that's what it made us, look at the mistake it made. Listen to the very end. Kit. So the final vowel is so, what we call devoiced. There's barely any air to it. The person didn't really say kit too, but kit. The poor computer was like, I don't know what to do. Of course, these are the complexities that you would expect in human language. So it's these kinds of cases where you would see a lot of failures. But we have systems for both Cook Islands Maori. I'm going to show you an example of Bribri, and this is important because it has much less data. This is with only about 68 minutes of data, a little bit over an hour. The character error rate is 23, so 23 out of 100 letters are coming out wrong, and 65 out of 100 words are coming out wrong. This is an example of one that worked really well. As you can see, all it's missing is separations between words, a letter here and there. This is an example of one that did not work well. Again, the poor thing, like there was a chair moving right in the middle. And of course, these are the cases that the humans would also really struggle with. So what could you expect if you were training a system like this? This is a graph, and probably the one on the right is the one that we should focus on. This is minutes in the data set versus word error rate. For a language like Bribri, and it is tonal, it has a relatively more complex phonology. When we get to about a little bit over 2 hours of data, the character error rate gets down to 30%. So about 7 out of every 10 letters are coming out correct. This is an example of a project I'm working with some colleagues and it involved transcribing languages of Nepal, Zardzonke, for example. This one was a test that we conducted on Tibetan, on Zardzonke, with reinforcement from Tibetan data. As you can see, once you get to something like 4 or 5 hours, the character error rate goes below 10%. So it can be something like 6 or 7%. So 9 out of every 10 letters would be correct. This is really, really good. At least makes things easier. And of course, this one weird quirk about this technology is that when it knows a person, it performs really well. If it doesn't know someone, it's not going to be as good. If you give it a new speaker, what we call held out speakers, the error rate is going to be approximately double. So we had an experiment where we took people out of our data set to simulate the computer not having heard them before. For example, you can see that it's the same person from before, but now it's making more mistakes. It confuses vowels, it confuses spaces. Missing letters and so forth. So you can expect different results, whether the person was there or not in the original set. First of all, we'd obviously be happy to share code with anyone. We have a GitHub for the AILT. We have code for how to make these models and then make demos with them. We have incorporated them in the workflows for the documentation. So this is one of our students working to record Cook Islands Maori culinary culture. This is a kind of ceviche. It's fish with lime. It's really good. We are halfway through or a couple of months from launching a public website where the community members can use this speech recognition system for free. It ultimately belongs to the community. It belongs to Professor Nicholas and the Cook Islands Maori community. So a little interface where they can drag their files, get the transcription, and so forth. And by the way, one of these details that is technically important, we're hosting it at Dartmouth for now because it requires what we call a GPU, a graphic processing unit. It's one of these processors that's a little bit expensive, and it does need a more powerful computer for the calculations to run a little bit quicker. So the voice that you were hearing talk about the pig, not the pig, the other ones saying that absolutely it won't happen, is someone called Jean. And she, as I told you, she has been incredibly generous with her time and with the sharing of her culture. So much so that we had enough recordings from her to make a synthetic voice. For example, this is her real voice.
Me Aotearoa e Otireiria.
This is our first attempt at doing what we call text-to-speech, which is trying to make an artificial voice.
Me Aotearoa e Otireiria.
Not amazing. A 2.1 out of 5, according to our raters. Then now,
Me Aotearoa e Otireiria.
better, a 3.2, if I remember correctly, out of 5 from our raters. We're working to try to make it more human-like. There's very good algorithms coming up for this. And you can see we did it with relatively little amounts of data. Why do we want to do this? First of all, to put it in learning tools, we have made small chatbots for people to use with the Cook Islands Maori language. And there is a robotics club on the island they work with like demolition bots, like these kinds of toys where they have like robot battles with one another. We're trying to work with them to have the speech models and the speech recognition models installed in the robot so you can talk to it in Cook Islands Maori. And these are very young middle schoolers, which is precisely the kind of population that we would like to interact with these. Let's see. Parsing. So this one is we're going to go from transcription to analyzing grammar. And for example, one of the challenges that I know that languages are sometimes have in this region is that their words are very long and they have a lot of parts in them, right? So the analysis of morphology takes a long time. The analysis of the relationships between word parts takes a long time. These are some subtasks, for example, what we call part of speech, determining whether something is a pronoun like you, a verb, an action like to sleep. This is the same phrase, isashkena, how are you all, in the Bribri language, where this is the pronoun you all, and this is the verb for the sun to rise. So literally, how are you is how did the sun rise for you? And constructing these types of database requires what we call parsing, which is the computer gaining a little bit of this knowledge. We have built corpora to do this. For example, our Bribri corpus right now has about 300 sentences, and this is an example of the longest sentence that we have, which is a sentence on how to cut cocoa fruit and how to ferment it, and ultimately how to make chocolate drinks out of cocoa. And this one is 55 words long, if I remember correctly. So we try to make data sets like this so that the computer can slowly learn what types of words are verbs, what types of words are nouns, and so forth, and eventually do the work of tagging them for us. Right now, our accuracy for part of speech for Bribri is about 90%, so 9 out of 10 of these pronoun verb tags are working. And then what we call relation labeling, for example, where the computer knows that something is the subject of the sentence or the adverb to describe how things happened, this one is at about 81%. We have begun work on something that would be very relevant to languages here, which is called tagging morphological features, determining whether a verb is second person, third person, plural, singular, etc. Right now, our detection rate is about 81%. So 8 out of every tags are coming out correct. And we have been working on the Cook Islands one as well. Our database there is larger, approximately 600 sentences. This is an example of one. Ireka koi te anani. Do you like oranges? So something like the word you, koi, would be tagged as a pronoun. The verb reka, which is to like something, is correctly tagged as a verb. And who is doing the liking? You, the subject. This process is about 91% accurate for what we have right now. And why do we want any of this in real life? Because there are people who would benefit from using this type of system, from learning these types of things. And these are language teachers. So when we developed our first prototype for this, we were teaching a class called Maori Grammar, CM221 at the University of the South Pacific. And these are the amazing people who are training to be school teachers all over the archipelago. They're really the only people who need to know what a noun is or what a verb is. So we had them work on the system, test the system to see if the outputs were going correctly. We eventually are going to put this on the website that I showed you to help them with homework. We're working to, one thing that we're doing, this can also be done for like explicit linguistic research. So right now, we trained it on the 6,000 sentences because we're scanning a corpus of 1.7 million words. One of our colleagues is looking for ways in which the passive structures are built and trying to find them in as many old documents as they can. And obviously doing this by hand will take a literal lifetime. So in a couple of weeks, we're gonna start to get the computer to run all of this in the 1.7 million words and hopefully find structures there that can help us do the work of grammatical description a little bit quicker. Here I'm going to tell you of an interesting case, not so much because of the technology, but because of the ethics involved in it. So machine translation would be very desirable for people who are learners, for example, if we wanted to get all transcriptions to be available in English as well. We have tried this with Bribri, where we have learning books, for example, oral corpora. One of the interesting challenges that we found, and this might be familiar to many communities, is that there was a lot of variation in the data. First of all, there were at least 3 ways in which people wrote independently. This is the word for pot, and this little line indicates that it's a nasal vowel, comes out of your nose. But also the little curl, but also the hook. So different books have different ways of writing. Within the computer, this little line is encoded in a bunch of different ways. Within the phonological system of the language, sometimes vowels are deleted because of natural linguistic processes. So the word mom can be ami, but also mi. There is sociolinguistic variation, as with any human language. The word road can be ñara and ñoro. And there are many documents where there is natural orthographic variation. People just wrote it how it sounded. And we have, for example, kekepa instead of akekepa for elder. We have an algorithm that tries to standardize some of the variation. For example, the computer encoding variation, it produces an intermediate form that then is decoded into different standards for how different people write it. We do not make an effort to flatten out sociolinguistic variation because this is something that the computer should know, how to listen to different people from different parts of the community. The results are a work in progress. So you can see that some sentences, for example, we would give them an original Spanish. This is a translation of what we gave it. The bird is sitting on the branch. This is what should have come out. This is what actually came out, so that one worked. Sometimes it does what we call hallucination. I wonder if you've heard about this term, where a neural network invents something. Kind of what we were looking at with the ChatGPT example. So here, it says the dog is sitting by the river, but somehow the computer couldn't do that, and it imagined the road. So here it says that the computer is sitting by the side of the road. It's missing things every now and then. This is a work that we're trying to continue. And this is a workshop with teachers from the community. In Costa Rica, they're very enthusiastic about this tool. In the Cook Islands, they are not. In fact, we could develop it, but they have told us not to, because the community and our bosses believe that this is not ethically appropriate. That the technology, for example, has a lot of places where it has biases. We know from examining how these large neural networks work that because they train on existing materials, they can get associations like men are doctors, programmers, and women are nurses and home caretakers, for example. It develops these kinds of associations because this is what we trained it on. Sometimes the approach is so terrible that I don't know if you've heard of the technical term garbage in, garbage out. For some of these systems, they just train them on whatever is available and then hope for the best. And they do come out with all these terrible associations. And For example, in the Cook Islands Maori language, the third word singular person, there is no word for he or she. There is just a word for a person, aya. This would mean any pronoun, they, singular. But in order to translate that into English, the system would have to make some decision. Is it going to make it randomly? Is it going to try to figure more things out, which these algorithms are very bad at doing? We cannot promise them, and therefore they have said, let's not do it for now. So this is an example of a technology that's possible, but there are other more important considerations that we need to take into account. Finally, so just to recapitulate, we don't need the computers to know any of this. What good is it going to do to us if we have some huge database that knows the language? They will just go the way CD-ROMs. I'm sure some of you have yourselves or parents, they have CD-ROMs molding in your houses. This is not going to revitalize the language. What we need is people using languages. This is, the one on the left is a beautiful example from an activist in Mexico who said that he lived his whole life on his phone and he had the right to live his life in his language. Therefore, the phone should be in his language. And he installed a type of system, the Firefox OS system for the phone, and translated it into Zapotec. So you can see that his whole life, which he appreciated, is right there. And for this language, Zapotec as well, there was a project where they had relationships between the Zapotec communities in Mexico and the ones in California, where they would get kids to train on how to use social media in their language and establish communication through it. And slowly they have been building a community of Zapotec posters, social media users that are doing it in their language. So one of the computationally simplest technologies is providing predictive keyboards. For example, providing a way where you can use your language on your phone, where you can type to your mom and tell you love her in the language. And these are not very computationally expensive. They're not that difficult to make. You do have to make choices of which software to use. We chose one called Keyman. So for example, I don't know if you probably use it here. There's one from Canada called First Voices, which has a very similar infrastructure. And we have tried to use the data that we have for the computer to get statistical suppositions of what words can follow other words. So this is someone saying that, oh my God, burgers, $3.50, let's go for this. So throughout, by the way, we, in case I didn't say it, we have launched these keyboards for Bribri, for Cook Islands Maori, for another Chibchan language from Costa Rica called Kabeka. We're slowly working through the process of getting the community to adapt these technologies. And throughout all of this work, the transcriptions for the speech recognition, gathering Jean Takura Mason's audio data for the synthetic voice, getting the sentences for the parsing so that it can know what a noun is, we have generated really large data sets that are of the kind that are unlabeled, just the raw audio files, for example, and labeled, which have some more processing to them. For example, the audio signal plus the transcription, and the transcription aligned so that you can make things like subtitles. Who is deciding what to do with all of these? We have tried to be, in the case of the Cook Islands, very strict with the data sovereignty. So for example, for Te Reo Maori from New Zealand, there is a series of principles called Te Mana Raraunga for how data sovereignty should be handled. That communities should have authority of the language, of the data, that there should be relationships, figuring out what to do with the data, that there are obligations that we have not just to the people, but also to the data in order for it to be useful in the future. I'm going to focus on Kotahitanga, benefit, and Kaitiagitanga, guardianship. So one of the principles is that there should be a Maori workforce trying to use making sure that the data is management, that the data is created, and we have tried to do workshops for natural language processing on the Cook Islands with local students of computer science so that they can be the ones who ultimately take on the project. We have tried to establish Kaitiagitanga, which is guardianship, stewardship of data, so that the community themselves, and in in this case, for example, our boss, Sally Yakova Nicholas, decide which data can be accessed openly, decide which one is not. There's something very interesting that they came out of Aotearoa, New Zealand, called the Kaitiagitanga license. This is from a group called Te Hiku Media, which worked on speech recognition for the Te Reo Maori language, the one in New Zealand, and who, by the way, were extremely kind to us when we were beginning our project. The very first experiment for the Cook Islands Maori speech recognition, they helped us run it. And they have a license that they have used to care for their data, all that they're generating, called Kaitiagitanga, which says, for example, that the responsibility of the data will remain with Maori people, that if outsiders want to use the data, they should establish contact with communities to try to see if there's ways that this could be mutually beneficial, which is radically different from how software companies do it, for example, where in computer science, we just assume data is like a big CSV, a big file that we take in, we process it to make our systems better, and then we end up in this silly, endless loop of trying to make the computer go 1 point better, 1% better, without this really being helpful to anyone. Full disclosure, it hasn't been tested in court yet, so it's a license that is assigned to the products, but as far as we know, no one has tried to breach it. We'll keep you posted on what happens if the content that we have released is ever breached from is that license. As I mentioned, we have tried to conduct workshops for natural language processing with people interested in computer science in the Cook Islands. The picture that I showed you from Costa Rica a while ago was also a type of workshop for this. And we're always trying to think of how, we can train people so that this is interesting, useful. We've trained them to do chatbots. We've trained them to do analysis of social media with what we call sentiment analysis, how to determine if a post is positive or negative, toxic or not, these kinds of things. And we are trying to continue making sure that community members are trained not just in the NLP, but also the linguistics. We had a big meet together at Kolang in Phoenix in 2024, where we brought, I think, together 6 members of the Cook Islands Maori community with about 10 students of linguistics from universities in the US. And for a month, they all studied together, worked on documenting the language. Some amazing connections were formed. And for example, Courtney Napa, has been incredibly also generous with her time in helping us make connections with speakers so that we can increase the collection of recordings that we have for the language. And so we keep going. So the work is going, there's a lot to do. Bringing it back to AILT, for example, these things, speech recognition. We are doing a workshop in Tohono O'odham, which is a community around Tucson, in June. We have Aldi coming up again in July. We're going to have a technology class and a class on data sovereignty as well. We have several database design workshops, flex workshops that are coming up. We are constructing a survey to try to see what are the needs of community members, because sometimes computer science people have these weird dreams of what they want to see fed into the little machines. Maybe those are not the things that communities need right away. We'll keep you posted on the results. And so the work keeps on going. I would love to hear what you think about it. But for now, thank you so much for having me.
Okay, thank you, Dr. Rolando. At this time, we'll take any questions. If there's anyone in person that would like to ask Dr. Rolando any questions on his presentation, raise your hand and I'll bring the mic over.
Just Rolando's fine, by the way.
You had the system where it took the words and it became English, but speaking Maori. Was that forced phrasing?
It's called untrained forced alignment. So forced alignment tries to find where in the audio signal you have the words. The untrained part is because we didn't have the data from the language to start training the machine learning model. And so we had to fool the computer into thinking that it already knew Cook Islands Maori by running it through the English. The very technical term for this is called zero-shot learning, where you try to get a machine learning system to act in a new way without ever having seen the training data. And for some situations, it's the only thing that we have for these situations where we have very few resources to go on.
When you have more resources as the technology gets better, can you use Indigenous languages in the same way that you used English and have better results?
Yes, definitely. So now we have managed to train a trained forced alignment model for Cook Islands Maori, and sure enough, it works a lot better. So for all of these, they do have an error rate, and you have to do some manual correction. But now that we have managed to tag more of the collection, we have trained it, and we are getting better results in that they take less human correction and annotation. But yes, and then obviously, like, the important question is, by the way, this will be in that little public data website that we're making. The question is, what levels of access should people have? Like, for example, using the model is very different from sharing the training data that the model came from. It's very different from sharing the model itself so that people can make modifications. So the questions for these three levels, what is the level of sharing that happens? Who gets to use it? We are going to release it for non-profit use, for example, but if anyone ever wanted to use it for profit, how are those decisions going to be made? Those are important questions for all these models. Did I answer your question?
It was like just a follow-up question. So then, so if you had languages from Southeast very different from, like, say, a Nupiaq, like, would you need to use languages that are closely related?
Yes. So, we are doing this work right now. So at Dartmouth, there's a student who just finished. He is Hawaiian, and we are working on what we call transfer learning, where the Cook Islands Maori models for describing the grammar, the noun, the verb, and so forth, they can work to improve the Hawaiian version of this. So there's much less data for Hawaiian. He's just getting started because he needs it for his PhD projects for describing the grammar of Hawaiian. And so sharing information between the Cook Islands model and the Hawaiian model makes it so that the Hawaiian model can perform a little bit better. And we have seen significant gains. The Hawaiian itself is not helping the Cook Islands Maori as much as we want it to because there's very little data. So this one cannot learn a lot more from this one. But they can definitely, the Cook Islands Maori is definitely boosting the performance of the Hawaiian. And just from the ethical perspective, this is something that this kind of license is exactly made for, like 2 Polynesian scholars working on the description of the language. This is exactly the case where we want to see data being shared between the two.
A lot of our Southeast Alaskan languages have unique sounds that are not really comparable to what's in English. So I'm curious, how do you approximate unique sounds? Do you use other neighborhoods of languages like you're saying, or is there like a comparison to English that you would use?
That is an excellent question. So let's see. I'm going to talk first about tones and then about consonants. Many of the languages here are tonal, probably. Tlingit is tonal, right? Where the pitch changes the meaning of words. So in the speech recognition, for example, we're able to get these kinds of performances because the computer is trained on what we call speech foundation models. So it already knows thousands of hours of English, Hungarian, Japanese, Spanish. And if it learns how the human sounds work from those, then it doesn't need to learn everything from, for example, the Bribri data. It gets like a little bit of a push upwards, even if they're unrelated. Not a lot of languages in these collections are tonal. Mandarin, Vietnamese, Thai are tonal, but we still see lower performance when transcribing tones than consonants and vowels. Maybe because there's not as much tone, English, Spanish, Hungarian, Russian, they don't have it. So there is an effect where sounds that are less familiar to the system will perform worse. And so what you would need is more training on sounds like that. We had a couple of students at AILT who were Chickasaw, and they were working on the Chickasaw language, and it has a sound which is like you take your tongue, try to do an L, and put it sideways. Shla. So yeah, Welsh has the sound as well. It's the little L like this. That one is was the worst performer in their system. They were training ASR when we last did the workshop, and indeed, it's probably because that sound is not very present in the foundation models. And so what we would need is, number one, be aware that the error is there, and number two, hopefully as we gather more data, the computer will be more familiar with those types of things. But yeah, this is ultimately very important. The computer is, these algorithms are made in very strange ways. The computer only learns what you tell it, which sounds very intuitive, but it has all these strange consequences. It learns awful biases from human books. If you train it on 1 million books that say awful things about humans, it will fail to learn certain sounds if the sounds are not there. So the answer is yes, it performs worse, but there is hope that the computer will eventually learn if you give it more data.
Yes, just to follow up on that idea, right? Half of the sounds in Tlingit are not found in English, as 4 unique sounds that aren't found in any other language in the world, and it has lots of those voiceless L's. So we got a lot of complications ahead of us. But what I wanted to ask about, though, is you mentioned the quantity of data that's been accumulated, right? And how are you handling where that's being housed and preserved and translated into new technologies, and how do you recommend handling that?
That is an excellent question with no easy answers. So, because the main problem is the electricity and keeping the computer going. So for any of you who has lost a document, like a draft, and cried about it, you know how difficult the problem of backups is. Let's see, in practice, the Cook Islands Maori data, we store as much as we can at our boss's home institution, which is University of Auckland in Aotearoa, New Zealand, which needs to follow Maori protocols legally under their legal framework. So they would have a duty to taking stewardship of it under Maori principles. So we try to store as much as we can of it there. For some things, for example, the training of the models. Right now, Dartmouth is the one that has the faster computer. So we need to train it there, and we do it under the understanding that this data is on loan and that we cannot share it, that we can only share it in ways that are determined by the Maori stakeholders. As for the practical things, yes, we do it with these large institutions because they're the ones who take care of the electricity, the server, and making sure that a backup is available in the future. And we have ways of managing data which can definitely be improved. If you have good metadata schemes for documents, Dublin Core is, if you're really serious, any in-house database system, if you want to keep it very protected, these are things that you should take very carefully into consideration. Let's see. In the future, we obviously want to move things like the Cook Islands Maori models and the data to the Cook Islands itself. But how are we going to ensure that this is available continuously to the people who need it, that the backups are being preserved properly? We're having issues keeping the backups properly synced up right now as we are. So this is something that we need to think of very carefully as we go. I don't know if I answered your questions. I just shared our pains.
Yeah, same. So we also have, the information that's held by individuals perhaps that may be reluctant to share it, because they're not sure how far widely it's going to be distributed, or, it's treasured closely by a relative that left a tape recording, or, wax cylinder type things, as far back as we can, that is in maybe some of the Smithsonian collections or things like that, and so how are you working with them to reassure them and still try to gain access to some of that material in a way that reassures them that it will be preserved and available to them, but not distributed widely? That's kind of like the...
That is an excellent question. Let's see. I think it's Mukurtu. For example, there is a one of these archival management systems that came from Australia, which is called Mukurtu, if I remember correctly. We can get the name later, which does have very strict permissions for different access, different members of communities, because they have such a strict taboo system there. So such systems do exist. In Costa Rica, we do have recordings that are in cassette tapes that are 40, 50 years old, and they can be stored in like academics' houses and so forth. And yes, it has been an issue, making sure that people share it, but also that these are not just kept safe, but the adequate people have permission to it. A lot of relationality, yes, a lot of personal relationships. And that is something that is difficult to understand from the CS side, because this takes human effort, it takes time, and building software is not like that. It's a world where like we do what we can with whatever data we have right now, period, the end, and then, we'll break through and see what happens. Yes, we have had, in our specific work, we have not found the instance of someone blocking off the data and saying, we're never going to give it to you. But I obviously know, through the work at AILT, for example, that these circumstances exist. I guess working with what you have, showing that you mean well and hopefully convincing them over time would be what I would do in that case. But it's something that will take time in either way. Yeah. And for example, museums are a place where sometimes it's difficult for them to relinquish their collections, to share their collections. This might be a case where there is no negotiation, and you might have to use another data set. But even that, the capacity to walk away from a data set because you said we either don't have the permission and never will, or they don't feel comfortable sharing this and maybe won't for 100 years, that is anathema to this kind of computer world. And it is something that I feel this world of indigenous language work could contribute to computer science. The idea that data is not just data. Data is people, data is knowledge, and some of the data maybe just shouldn't exist in the model. Again, I'm not sure I answered your question.
Yeah, no, that's great.
Yeah.
I had one more question. I just forgot it.
Okay.
It'll come to me.
We have a question online from Rune Lance Twitchell. He said, "Gonna cheese for this presentation. Have you seen effective technologies to show grammar and contraction in North American languages that are polysynthetic?"
What do you mean by contraction? Do you mean like less population, or do you mean like morphemes that blend into one another? Yes, like things shrunk. Yes. Let's see. Yes. So, interesting. So the work I'm more familiar with is one for a group of languages called Uto-Aztecan. So the one called Nahuatl in Mexico is very large, and it is polysynthetic. Several languages of Arizona, California are polysynthetic. Yes. So there is, let's see, what we called, on one end of the spectrum, we have what we call rule-based learning, where you tell the computer very specifically, like, these are the morphemes of a language, these can be transformed into this, process the data so that you can split it in these ways. And then it will try to follow its rules, and then the risk is that these kinds of contractions and changes will not appear in our beautifully crafted rules, and then it will be invisible to our system. And obviously, in order to craft the rules, it needs to be someone who knows a lot. So these types of rule-based systems, finite state transducers is one example that comes to mind. They do exist, and they can do a lot of work. Even though they're older techniques, they're very effective when you have low volumes of data. People have tried, on the other hand, to use the newer methods like deep learning, machine learning methods. I mean, there are a lot of very good papers out there describing systems where either you give it as a prompt to one of these fancy models, ChatGPT, DeepSeek, etc., and it can learn some of the splitting, or I'll be with you in just a second, or you can do what we call a fine-tuning on something where you tell it, okay, you know a lot about languages, now I want you to take this input and transform it into that output, And there has been work on it. So the older method, as far as I understand, is still very, very good. People are trying to make the other one better. Yes, did I get...
Yeah. He went further and he said he's referring to morphemes.
Yes, morphemes. Yes, so good. That's what I've been talking about. So yes, splitting of morphemes. So yes, no, there's. Be happy to send you more papers if you send me your email later. There's a lot of good work for Nahuatl, for example, or for morphological splitting. I know there is some work for languages of this region. I wanna say Tlingit has a morphological splitter out there in a paper because it's either Haida or Tlingit. We'll have to look. So those two techniques on two sides of the spectrum, like finite state transducer and deep learning prompting, are things that people are using nowadays for this kind of application. And obviously this is what you need, what is probably your priority, trying to analyze the functioning of these morphemes. So there are techniques for this.
I remembered the other question I was going to ask you was, how are you mentioned, like you started the presentation talking about the gibberish that's coming out, right? How do you combat that by, putting a statement out that this is not accurate, this is way off, this is not our language?
Oh gosh. I know there is an initiative having to do with data sovereignty. I can send you the name later, which has... is a system for labeling, like websites that produce this kind of output and everything, so that people can be warned that this exists. It is difficult because precisely the model of garbage in, garbage out leads to people wanting to incorporate more languages and saying, hey, we have systems that know 1,000 languages and they're going to incorporate the diversity of the world, but they don't really know them. A lot of education to people who are working in technology in our communities for them to see that this is not wonderful, this is not magical, it makes mistakes and you should use it to learn language from it. There's things that are terrible happening right now. I don't know if you've seen that people are trying to sell like Oneida grammar books, like the 100 most common Oneida. It's happened here as well. And it's complete garbage. And that is, yes, that's going to be an effort that's going to require some kind of community outreach and a lot of education in order for people to understand that a lot of what this is producing is rubbish. There are companies which are open to working with people, contacting companies directly, the ones that are the big makers of this, OpenAI, Google with Gemini, for etc. Communities have worked with them in the past. Some of them, there's been a lot of good fruits to those kinds of efforts. Yes, it's a weird world out there. And this kind of thing, like 100 most common verbs in, that is kind of scary. Yeah.
We have another question online from Vanessa Kelly. She said, in the PowerPoints, the speakers you listed were 7 to 13K. Is your program working with any languages that have less than 100 speakers?
This is like an actual question. It's not like, oh, I have a question and then I'll rhetorically answer it. So there is the question, if you have so few speakers, what should the money be going to? Should it be going to making these types of systems to help someone because they're so overworked and they need to transcribe everything as fast as possible? Or should it be going to recording as much as you can? And then in 20 years, 50 years, someone will make a system to finish transcribing all of this, because it's very painful. In the Southwest, there's languages that are spoken by 2 people, by 1 person. And so whoever is working on this program, their mission is very clear. So I promise this is an open question. The ethics of using artificial intelligence in such a difficult environment, I don't know. I mean, do these tools exist? Yes. Would they work the same? Yes, because it depends on how much data you have to train them, on your specific needs. So if it's something where it's your situation and there's less than 100 speakers and you're like, if I could have a computer system that tells me with this, I really need that, then by all means, I encourage you to do it. And the algorithms would work the same. But I have worked with communities that have this kind of thing, and it's always an open question, like, where should the resources go? And the truth is, yeah, if everyone, I mean, don't trust anyone who tells you, yay, AI is going to fix it. AI is going to fix all our problems, because it definitely won't, I guess, is the one piece of advice that I could give you. But think about it very seriously. I hope I answered your question. If not, please follow it up.
Okay, so we have another question from Rene Lance Twitchell. He said, can AI technology reveal learning patterns for Indigenous second language learning that can improve the development of learning materials? And furthermore, could it ever become conversational?
Oh, good questions. Let me try the second one. Let's see. Can it ever become conversational? Define conversational. So if what you mean is having, for one of these chatbots to be able to have a good interaction with you, even for English, it's not 100% possible. So on one hand, you've probably used like a bank's chatbot, where it's like, what do you want? I want to check my bank account. Okay, let's see if this works. And then 10 interactions later, the chatbot is going nowhere. So it is very difficult to engineer these types of things. The other case is where you tell your chatbot your feelings, and it's like, it's okay, it's gonna be fine. So these types of psychology things, conversation, etc. It is very difficult to emulate human capabilities on this, and you need a lot of data. You also, if you're interested in this, look up an algorithm which is called reinforcement learning. It's how ChatGPT gains this capacity of like, explain the moon landing to me like I'm 5. Where it's trained to eventually model one style of conversation versus the other. So it is possible to do it, but it is expensive, and it is not, it's so difficult to make that it can actually cause human suffering. So there was a big problem with the early training of ChatGPT, where people in Kenya who worked at this technology startup were made to help develop this algorithm to filter the worst impulses from ChatGPT. They would be paid not a lot of money to watch literally the worst things that humanity could offer. And it was something where a lot of people suffered trauma later from trying to make sure that this type of thing worked. And so it is not easy to build this kind of capacity in a computer. It is possible with a lot of data that it could learn to have conversations, but even for English, we have not really reached that. Is it worth it? For communities that have big diasporas, it might be the case that you do need to train systems where you can have conversations even if no one is around. And your first question was, can we detect patterns in L2 learning? I would defer to the L2 learning specialists, because they're the ones who know how to design experiments on it. The computer itself, there's two things here. If you give the computer data on second language learners, could it find patterns? Yes, statistical patterns, but you'd need a human with human intelligence that knows about L2 learning to interpret it. On the other hand, if your question is, if a computer learns Haida, can we correlate the errors of a computer learning Haida to the errors that a human would make? The answer is no, because this is a massive research program right now. This is a technology where, for many reasons, we don't know how it works exactly. There's a lot of research trying to figure out how ChatGPT and any of these models reason exactly. Whatever they're doing is probably not how humans reason. So even if we learned how, DeepSeek learns Haida, that would still not illuminate how a human learns Haida. I hope I answered your question. If not, tell me and we'll figure it out together. Yes.
So given all of these complications and wrinkles and all of that, for someone who might be interested in starting doing some of this or learning how, where would you recommend they start, and what kind of equipment or tools would you recommend to start with, where basic level?
Let's see. So where would you start? With your technology people at the organization that you're working with. Hopefully there's someone who knows their way about code, etc. If you don't have someone like that, get some entrepreneurial tween, someone who wants to learn more about computers and who's willing to work hard. This is the way a lot of us learned how to program, just like by breaking a computer and then figuring out how to put it back together. So Yeah, I mean, pay them properly. Yes, start with young people who might be interested in computers, who might be interested because they're incredibly resourceful with making these kinds of things, and they will be a tremendous resource later in the community. If there's this training that they could use for very practical purposes later in life. This is something that they could get a job later out of. So it's not difficult to pull people into these kinds of workshops, training, etc. A lot of the software is freely available, incredibly. A lot of these models we can use for fine-tuning, for playing. Again, if you go to AILT, you can download a lot of like our workshops, and they include like the software that we've been using, etc. So it's not that difficult to start, and a lot of it can be run relatively cheaply, either on cloud solutions or on your own computer. So as for data sovereignty, you'd have to figure out if your cloud computing provider will provide adequate protection for your data and so forth. As for doing it on your own computer, if you can wait for a couple hours, like for example, the training of the Cook Islands Maori models takes 5 to 6 hours. So it's not, like on the fast computer, it would take probably a couple of days on a slower computer, but it is not impossible to just leave it there and you do it with computers that already exist. So this is something that has changed a lot in the last 10 years, that the computational needs have been, are more at reach for people compared to the very large systems that we needed before. Yeah. There's a lot of ways to start.
And then just a quick comment from Rene Lance Twitchell. He just said it was really good, your presentation.
Thank you so
and
much.
that he has to go teach right now.
Yay, teaching. I understand that.
And then I have a question for you. So in the Tlingit language, there's a lot of small nuances. One of them that isn't really explained enough, or just that you don't hear enough, is that sometimes certain consonants, if they come from the same area of your mouth, it just kind of becomes, one of them combines and becomes like a glottal stop. Okay. And so an example would be like when Cyril George, he was telling the story of Al-Qutatzin, he said, if you were to read the sentence as is, it would, I expect a learner would read it as yik qasatin ikla khat dah yejene. And I guess what I'm asking is, would the speech recognition be able to pick up these little nuances? Like also in like another common phrase, yekwati, a lot of people say yekwati, but a lot of the elders in the old recordings would say, they could say yekwati, or they would say, or just the K would drop and it would just become yekwati as like a glottal stop, just because the consonant comes from a very similar part of your mouth. Or sometimes it would just, both would be rounded, yekwati. How do you think the speech recognition would pair up to that task?
Depends on how much data you give it. So, for example, this variation that you mentioned, English has something a little bit similar, where the word P-A-T, pat, you can also pronounce as pat in some circumstance. Like, I'm going to, who's coming? Pat. Where it's not really like a P-A-T, but a P-A, and then something in between a T and a glottal stop, pat. And the computer can recognize it, but only if you give it enough data. It would be interesting to measure, like in that decreasing curve, if you have 30 minutes of training, 60 minutes of training, how much it will recognize it. And ultimately comes down to how frequent it is in the data that you're feeding the computer. If it's a phenomenon that happens all the time, then it could pick it up. If it's more infrequent, it would probably have problems picking it up at first. So it can, because it is attuned to a lot of sound variations. It does something where it takes all of its knowledge from the foundation model languages and then splits every possible human sound into like 50,000 tiny possible sounds. This process is called quantization, and then tries to assign whatever you're hearing to one of the 50,000 quantized representations. So that's why if the sound doesn't exist in the collection, it's going to have a lot of trouble determining which one is correct. Whereas if it's just an ah, you will definitely know where to go. eventually it will create a strong association between this data and one of the potential representation possibilities, but only with enough data. And I do not know, it depends on the data. But the answer is yes. Mm-hmm. So that is, what I'm talking about here is for like learning rates, like how frequent would an error be in the transcription of this kind of thing.
Well, I guess I have another follow-up question for you. So, what was it? I'm trying to think. Sorry, it just, sometimes, okay, so sometimes in Tlingit, I know there's also vowel variation too, or I guess more vowel quality variation. So for example, there was an elder we were listening to, and he said, instead of saying gunash, he said gunash. It's almost like his mouth really opened wide and it became to ah instead. Do you think that would pose a challenge, or would that just be another scenario where you'd have to feed the data?
Let's see. It depends on, is this variation of a single individual, or does it correspond to different variants of the language?
It could come from literally almost any elder.
Yeah.
Oh, and then on top of that, all right, here's another challenge. With some speakers, when they're giving a speech or telling a story, they tell it from really high. So, and because Tlingit is a tonal language, I think that can pose a challenge too, because with Matthew Fred, he would go yada, 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 yada. And then same with Austin Hammond, he'd also go da, 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 really high, even though Tlingit is a tonal language. Would that pose a pretty big issue too?
Yes. So let's see. The first one is that obviously there is variation that we want to preserve. Even in the English models, for example, they should learn to distinguish, to transcribe from Scotland, from New Zealand, from California. And we do know that Siri, for people who are speakers of Scottish English, doesn't work as well. For Scottish women, it does not work as well as it does for men from California. And this is because of the different amount in the data, training data. As for variation within an individual, it's interesting. I didn't have time to mention it, and I'll mention it now. One, the speech recognition system that we have for Cook Islands Maori has weird quirks because of how we made it that we didn't see coming. In English, there's a big bias, which is that men are understood better than women. But we have the reverse bias because women have been so much more generous with their knowledge in this context. And so whenever we test it with men, it doesn't perform as well. One thing that it does is that it was planned to transcribe elders who were telling traditional stories. But our demos were always with young people who wanted to study computers. And so our demos did not go so well. And now we know we need to incorporate more young people because we didn't have them before. Our demos usually involve people who are language learners. And we only started with people who are L1. So language learners are detected very poorly. So right now we're trying to incorporate them as well. So you can see how we were dragged by the assumptions that we had about what this thing should do. And now it's behaving in the way we designed it to, but we didn't see all of these other cases. If you want something where, I imagine the very high tone could come from either ceremonial speech or singing. We do not have any singing, for example, in the Cook Islands Maori data set, so it's probably going to be terrible. For the Bribu, we have a little. If you want your computer to know these kinds of variations, you're going to have to train it on all this data. And we didn't even foresee it, like all these examples that I mentioned when we started. As for like the relationship, an individual can speak higher pitch sometimes, lower pitch sometimes. In theory, if it has enough of a sample, it could learn it. But in practice, it depends on how much you give it, yeah? Yay.
All right, that looks like all of the questions we kind of stormed you with.
All good, so good.
And okay, well, that concludes our lecture with Dr. Rolando Coto-Solano. Our next lecture will be with Nathan Bennett. He's coming in from Seattle. He is Haida, and his lecture will be coming on Wednesday, April 30th, same time, 12 to 1. Shisha.
All right. Thank you all for your patience. Thank you for being here. Oh, yes. Yes.